extremely important part of the pet food processing industry. We grind to improve digestibility, to improve mixing characteristics, and to help make handling easier. The two most common machines we use for grinding are hammer mills and roller mills. The question we are proposing is which type of grinding process would be most effective in the pet food industry. The biggest difference between hammer mills and roller mills is that hammer mills use impact grinding, while roller mills use shear and compression. How impact grinding occurs in a hammer mill is that a large, full-size kernel or ingredient falls into grinding chambers where hammers attached to a shaft are moving at a very high velocity. These hammers make contact with the ingredient, breaking it into smaller particles. The particles then either fit through the screen or bounce off the screen back into the grinding chamber, where they are hit again until they are small enough to fit through the screen.
Hammer mills are used in many processing facilities because of the ability to achieve a small particle size. The hammers and screens are relatively cheap to replace when they are worn down, and they are easy to work on when something needs to be replaced or repaired. Some of the disadvantages involve energy costs associated with running a hammer mill, and the particle sizes are not uniform. A roller mill uses shear and compression to grind products to a smaller size using two cylindrical rolls that have corrugations or grooves cut into them. The product moves through the rolls as they are rotating. Generally, one roll spins faster than the other to create a shearing or cutting action on the product. This is called a roll differential. When the product goes through the rolls, it gets crushed and cut to open the brand of product and expose it in the spin, or to reduce the particle size of other products.
Some of the advantages of roller mills are the uniform particle sizes it can produce. In comparison to the hammer mill, about 95% of the product is uniform, as compared to the 70% you would get with a hammer mill. Roller mills also have lower energy costs than a hammer mill. Some of the disadvantages would be the expenses involved with recorrugating a roll and the difficulty of removing the rolls from the mill and transporting them to get recorrugated. Another disadvantage is that the roller mills have trouble reaching the small particle sizes that a hammer mill achieves without rerunning the product multiple times. An estimated cost for installation of a hammer mill and roller mill are roughly 2 times the cost of the equipment itself, according to Dr. Charles Stark. So in this case, the installation cost would be approximately $135,488 for the hammer mill and $131,444 for the roller mill. It costs less to install and operate a roller mill due to the savings in energy. However, a hammer mill makes up for its higher energy cost with its ease of operation and inexpensive and easy maintenance. Facilities want a hammer mill because if something breaks, they can reduce the amount of downtime because it is quick and easy to fix.
There are several different factors that play a role in the throughput in hammer mills and roller mills. For hammer mills, the screen opening size, tip speed, hammer patterns, the type of feeder, air assist system, and motor RPM are all key factors. Factors that affect roller mill throughput are whether it is a smooth versus a corrugated roll, roller speed, roll differential, diameters of the rolls, and the pitch and spiral of the corrugation. In the pet food industry, particle size reduction plays a key role to the extrusion process. When particle sizes are not uniform, the particles will not be cooked at the same rate. According to Eileen K. Schofield in the Feed Technology book version 5, this can, quote, degrade both the product's appearance and palatability. If the particle sizes are too large and not uniform, they can catch on the die and plug the extruder. Even though from this data, it may look like a roller mill is the better piece of machinery to choose, particle size, shape, and handling characteristics are not all that come into play when choosing the best piece of equipment. There are so many other aspects of each machine that come into play when making the best choice.